Hello, in this video we're going to talk about something called one-way Anova. It stands for analysis of variance. This is a method of testing the equality of three or more population means. We already looked at how to compare two population means, so this is only if you have three or more, by analyzing samples of variance. One-way analysis of variance is used with data categorized with one factor or treatment. So there is one characteristic used to separate the sample data into the different categories. The requirements, which you don't really need to worry about too much. If I ask you to do analysis of variance or Anova on a set of data, then we'll just assume that they meet the requirements. But the populations have distributions that are approximately normal. This is a loose requirement. Populations have the same variance. Samples are simple random samples of quantitative data. Samples are independent of each other, so that means that the samples aren't matched or paired in any way. And the last one, different samples are from populations that are categorized in only one way. The null hypothesis will always be that the means are equal to each other, and the alternative is that at least one of the mean is different. This is always a right-tailed test, just like the other ones that we've been doing lately. So for analysis of variance, the only thing that I'm going to ask you to do is look at output from some technology and then make your decision on whether you're going to reject the null or fail to reject the null, and then make a conclusion. So use the performance IQ scores listed in table 12-1 and a significance level of 0.05 to test the claim that the three samples come from populations with means that are all equal. Here is a bunch of different output from different technologies. The first one is from StatDisk, and we can see our test statistic is right here, and our p-value is right here. Next, we have some output from Minitab. Again, our test statistic is here, and our p-value is right here. Next, we have Excel. The test statistic is here. I apologize that it's so blurry, and the p-value is right here. So here for StatCrunch is the test statistic, and here is the p-value. On a graphing calculator, if you have a TI 83 or 84, the test statistic is right here, the first line, and then the next one down is your p-value. SPSS, that's another statistical software. We have our test statistic here, and there is the p-value. That one's a little bit different in how it denotes the p-value. So here's another statistical software, JMP. We have our test statistic here, and this is the p-value. Our p-value is 0.02, and this is less than alpha, and alpha is 0.05. So since the p-value is less than alpha, that tells me that we're going to reject the null hypothesis. And the conclusion that we're going to get from rejecting the null hypothesis is at least one of the means is different. So that's all we would conclude. If we fail to reject the null, then we could conclude that the means are all equal to each other. In the next example, we're going to use chest deceleration data for three different size categories: small, mid-size, and large. The data are from a standard crash test, and they are listed in dataset 13 in Appendix B. If we use the pelvis injury measurements with the same three size categories, we get the Excel stat results shown below. Using a 0.05 significance level, test the claim that the three size categories have the same mean pelvis injury measurements. Do the size of the car appear to affect pelvis injuries? H0 is going to be that mu1 equals mu2 equals mu3. So we had three different size categories. And the alternative hypothesis is that at least one is different. So alpha for this is 0.05, and here is our p-value. So that's 0.000008. So it's approximately 0, and since our p-value is so small, then we would reject the null hypothesis. And we conclude that at least one mean is different. So basically what that's saying then is that how severe your injury is will depend on what size car you're driving. In our next example, data set 14 in Appendix B lists highway fuel consumption amounts in miles per gallon for car categorized small, mid-size, large. If we use those highway fuel consumption amounts arranged into three separate size categories, we get the TI-84 should be 8384 plus calculator results shown below. Using a 0.05 significance level, test the claim that the three size categories have the same mean highway fuel consumption. Does the size of a car appear to affect highway fuel consumption? Our null hypothesis is that mu1 equals mu2 equals mu3, and our alternative hypothesis is that at least one is different. Our p-value is right here. So we have that -4 at the end. So that tells me to move the decimal 4 places to the left. So I would have 0.000577. And our alpha is 0.05. And since the p-value is less than alpha, we would reject the null. And we would conclude that at least one mean is different. So basically what that's saying is that the size of your car will have some impact on how much fuel you use. So that's all for this video. I hope you guys are having a great day.